Informally, a vertical line is one that extends up and down, like a flagpole. On the other hand, a line that extends left to right is horizontal. In Figure 1.59, line L is vertical and line J is horizontal. Where lines L and J intersect, they appear to form angles of equal measure. Definition: perpendicular lines are two lines that meet to form congruent adjacent angles. Perpendicular lines do not have to be vertical and horizontal. In Figure 1.60, the slanted lines M and P are perpendicular. M is perpendicular to P. As we have seen, a small square is often placed in the opening of an angle formed by perpendicular lines to signify that the lines are perpendicular. Theorem 1.6.1. If two lines are perpendicular, then they meet to form right angles. Given, line AB is perpendicular to line CD, intersecting at point E. See Figure 1.61. Prove angle AEC is a right angle. Proof. Statements. Reasons. Number 1. Line AB is perpendicular to line CD, intersecting at point E. Number 1. Given. Number 2. Angle AEC is congruent to angle CEB. Number 2. Perpendicular lines meet to form congruent adjacent angles. That's a definition. Number 3. The measure of angle AEC is equal to the measure of angle CEB. Number 3. If two angles are congruent, their measures are equal. Number 4. Angle AEB is a straight angle, and measure of angle AEB equals 180 degrees. Number 4. Measure of a straight angle equals 180 degrees. Number 5. Measure of angle AEC plus measure of angle CEB equals the measure of angle AEB. Number 5. Angle addition postulate. Number 6. Measure of angle AEC plus the measure of angle CEB equals 180 degrees. Number 6. Substitution. Number 7. Measure of angle AEC plus measure of angle AEC equals 180 degrees, or 2 times the measure of angle AEC equals 180 degrees. Number 7. Substitution. Number 8. The measure of angle AEC equals 90 degrees. Number 8. The division property of equality. Number 9. Angle AEC is a right angle. Number 9. If the measure of an angle is 90 degrees, then the angle is a right angle. The relationship between perpendicular lines suggests the more general but undefined mathematical concept of relation. In general, a relation connects two elements of an associated set of objects. Table 1.8 provides several examples of the concept of a relation R. Table 1.8. Relation R. Objects related. Example of relationship. Is equal to. Numbers. 2 plus 3 equals 5. Is greater than. Numbers. 7 is greater than 5. Is perpendicular to. Lines. Line L is perpendicular to line M. Is complementary to. Angles. Angle 1 is complementary to angle 2. Is congruent to. Line segments. Line segment AB is congruent to line segment CD. Is a brother of. People. Matt is a brother of Phil. There are 3 special properties that may exist for a given relation R, where A, B, and C are objects associated with the relation R. The properties consider one object, reflexive, 2 objects in either order, symmetric, or 3 objects, transitive. For the properties to exist, it is necessary that the statements be true for all objects selected from the associated set. These properties are generalized and given examples as follows. Reflexive property. A relation A. 5 equals 5. Equality of numbers has a reflexive property. Symmetric property. If A relation B, then B relation A. If line L is perpendicular to line M, then line M is perpendicular to line L. Perpendicularity of lines has a symmetric property. Transitive property. If A relation B and B relation C, then A relation C. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. Congruence of angles has a transitive property. Does the relation is less than for numbers have a reflexive property, a symmetric property, a transitive property? Solution. Because 2 is less than 2 is false, there is no reflexive property. If 2 is less than 5, then 5 is less than 2 is also false. There is no symmetric property. If 2 is less than 5 and 5 is less than 9, then 2 is less than 9 is true. There is a transitive property. Note, the same results are obtained for choices other than 2, 5, and 9. Congruence of angles, or of line segments, is closely tied to equality of angle measures, or line segment measures, by the definition of congruence. The following list gives some useful properties of the congruence of angles. Reflexive. Angle 1 is congruent to angle 1. An angle is congruent to itself. Symmetric. If angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Transitive. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. Any relation, such as congruence of angles, that has reflexive, symmetric, and transitive properties is known as an equivalence relation. Theorem 1.6.2. If two lines intersect, then the vertical angles formed are congruent. Construction 5. To construct a line perpendicular to a given line at a specified point on the given line. Given line AB with point X in figure 1.63a. Construct a line EX so that line EX is perpendicular to line AB. Construction. Figure 1.63b. Using X as the center, mark off arcs of equal radii on each side of point X to intersect line AB at point C and D. Figure 1.63c. Now, using point C and point D as centers, mark off arcs of equal radii with a length greater than length XD so that these arcs intersect either above, as shown, or below line AB. Calling the point of intersection E, draw line EX, which is the desired line. That is, line EX is perpendicular to line AB. Theorem 1.6.3. In a plane, there is exactly one line perpendicular to a given line at any point on the line. Theorem 1.6.4. The perpendicular bisector of a line segment is unique.